at some point in either late junior high or middle school or early high school, you will have learned about quadratic functions and vertex form and standard form and factored form. So I'm coming into this video assuming this is already prior knowledge, but I'll review it a little bit. We're told that a quadratic polynomial, in other words, this curvy thing, is given in vertex form. So this right here, that's our vertex form, and then graphed in the coordinate plane. And we want to rewrite it in standard form and factored form. So this part's actually pretty easy, taking it from vertex form to standard form. All that means is multiply this out. So what is x minus 1 squared? Well, that's x minus 1 times x minus 1. Okay, and you still have that minus 1 over there. That's what this really is. So if I then take that and let's put it over here. I'm going to expand that out. X times x is x squared. Okay, then I do x times negative 1, and that's going to give me negative x. Then I do negative 1 times x, and that gives me another negative x. Okay, and then I do negative 1 times negative 1, that gives me a positive 1. And don't forget that negative 1 all the way at the end. That's still there. So as you combine everything together, take a look at what we have. We have x squared minus 2x, and then the plus 1 minus 1 cancels out. So here's our standard form. X squared minus x. Basically, x squared minus 2x. All the parentheses are gone. That's what standard form basically means. And now I want to know, what is the factored form? Well, a lot of people, when they think factored form, they think of something like this, these two parentheses right here, and they automatically reach for x plus something, x minus something, and have trouble with something like x squared minus 2x. Well, you have to remember, the very first thing you look for when you're factoring is a GCF. Okay, so what's the greatest common factor here? It's just x. You pull out an x, and what's left behind? It's going to be x minus 2. So there's my factored form. And now we're ready to move on to the rest of this problem, which is describing some key features of the graph. And then there will be a little bit more at the end. So the key features is asking you basically just to look at the graph and describe it. So where's the minimum? Well, you know what a minimum is. That's the lowest point. And it reaches a minimum of y equals negative 1 at x equals positive 1. It's increasing all over here. This is all increasing, the right side of that minimum. So how do I say that? Well, what I do is I say everywhere from 1 to infinity. See, it just keeps on going up forever. And notice I'm using curvy parentheses here, not square brackets. Square brackets would imply that it's increasing at that point right there, but it's not. It's just flat at that point. There's no uphill or downhill. It's the bottom of a valley. So it's decreasing, likewise, over on this side, and that implies curvy parentheses, negative infinity to 1, close parentheses. Where is it positive? Now, some people get mixed up here. They think, oh, x is positive, right? So it's going to be all this stuff. Those are all positive x numbers. Well, yes, they're positive x numbers, but what I'm asking here is, where is f of x positive? In other words, the function itself. So give me a nice fat line here for a moment. I'm talking about not all of this. See, that would be the positive x values. That's not what I mean. I mean, where is f of x positive? That's all of this stuff. See, those are the positive y values. And here's the other trick. Not only do you have to be thinking about the positive y values, but you have to describe it in terms of x values. So what we're going to say here is from negative infinity to 0, union the number 2 out to infinity. Okay, those are all x values where f of x is positive. And likewise, let's talk about where f of x is negative. It's going to be this stuff, all of that. So that's negative between 0 and 2. Between x equals 0 and x equals 2, all the y values are negative. And notice I did not do square brackets. Again, square brackets would imply something about this location right here or this location right there. But y is equal to 0 at those locations. It's not positive or negative. So here's a good rule of thumb. If we're talking about increasing or decreasing, positive or negative, never use square brackets. And now coming down here to the very last part, I want to know, when speaking about these three different forms right here that we talked about, when speaking about those three different forms, what are they good for? Well, standard form is very good for telling you where the y-intercept is. That's kind of what it does. And if you look at this, what's the constant value of this standard form? The number at the very, very end without any x's on it. Well, there is none. It's 0, right? So we would say the y-intercept is 0. And look at that. There it is. Y-intercept 0. So standard form is very good at showing you the y-intercept. Factored form, I'm going to use a different color here, otherwise this is going to get confusing. Factored form is very good for showing you the x-intercepts. They just sort of pop out at you in factored form, and we've gone over this in class before. Vertex form is extremely good for some other things. I'm going to use a different color. Vertex form is great for transformations, telling you what is the horizontal shift, what is the vertical shift, and what is the minimum maximum, I guess. All of those things are done by vertex form. And let's just go over that quickly. Here's my horizontal shift right there. That's the horizontal shift. Here's the vertical shift. And horizontal shift, vertical shift together give you vertex form. Remember, vertex form tells you where the center, or where the, it's not the center of the, I guess it kind of is, where the vertex of the parabola is at h comma k, which is dictated by those horizontal and vertical shifts.